Hello, Flat Earth researchers, debaters and debunkers. Following my recent video asking if pilots factor in the extra distance they would have to cover if they are flying above a globe Earth, we have a response from Wolfie, and so I commend him for doing this. And let's just listen to his response first, and then I'll add my thoughts on that.
So this is just a video response to Phuket Word's latest video, just asking pilots if we have to compensate for the additional distance when flying at altitude due to the increased radius compared to travelling across the surface of the Earth. Now, I have discussed this with you previously and I've gone through the math previously, but I'm happy to repeat it in a video this time. The demonstration here is using a ball with a number of straws. Now, I appreciate you have said this is not to scale, but let's consider what it actually would look like on this scale. Those straws would have to be less than 0.5 millimetre in height. Now, how much is 0.5 millimetre? It's smaller than the ball in this ballpoint pen. Okay, so this diagram, and I respect you said it's not to scale, but in reality it's grossly out of scale. Okay, remember we're just 0.5 millimetre above the surface of this ball if we were doing it to scale. So let's take a look at how much the difference in distance actually is. Let's have a look at the math. And we're assuming the Earth is 6371 kilometres radius, which will give us a circumference of 40,030 kilometres. Now, going up to 40,000 feet, that is an altitude increase of 12 kilometres. The radius of the aircraft flight path is therefore 6371 plus 12, which gives us 6383 kilometres. That makes the circumference of the circle that the aircraft is flying to be 40,106 kilometres. So what's the difference as a percentage? We need to divide 40,106 by 40,030, and it gives us that number of 1.0019. That means the distance increase at 40,000 feet compared to the surface of the Earth increases by 0.19%. So what does that actually mean? Let's take a flight from, say, Sydney to Hawaii. That's a flight I did recently, and it's about 4,000 miles. I'm just rounding to the nearest number there just to make it simple. Over that distance, the increase in the distance of the actual route due to the altitude is only 7 miles. So in 4,000 miles of flying, it's only an increase of 7 miles. What does that mean in terms of time? If the flight duration is 10 hours, the actual difference in time is 1 minute. So in reality, yes, there is an increase in the distance and there is an increase in the time, but it's so tiny that you actually wouldn't even have to factor it in, and you would still arrive within 1 minute of the estimated flight time. However, just to go one step further, if you go to Wikipedia and you look up flight planning and then scroll down to the section that says units of measurement and read what it says about how flight plans are calculated and how they calculate the distance units. It says, distances are always measured in nautical miles as calculated at a height of 32,000 feet. So the distances are factoring in the actual cruise altitude of the aircraft. And 32,000 feet, it's sort of the lower level of typical airline flights, but it's factoring in enough of an adjustment to remove that 0.19% error down to less than probably 0.1 for most of the altitudes that airlines are going to fly. And that means even over a 10-hour international route, the difference is going to be less than 1 minute. And then it goes on to say, with due allowance for the fact that the Earth is an oblate spheroid rather than a perfect sphere. So to answer your question, yes, we do factor in the additional distance. It's less than a minute on a 10-hour flight from Sydney to Hawaii, and it is factored into the flight plans. So hopefully that answers your question.
So, first of all, thank you very much, Wolfie, for another polite and measured response, which is rare among those who jump to defend the globe and often verbally attack and abuse flat earth researchers or anyone asking common sense questions to see if they can find out for themselves and judge for themselves whether we do anything on this earth that can tell us it is a stationary plane or a spinning ball. But it does, in fact, reinforce the point I have always tried to make with you and through my videos. This, of course, is one of those questions that anyone looking into the flat earth will think about and try to find answers for at the early stages of their investigations. And this is what my videos have often been about, just to take people through the process of what goes through someone's head when they are looking into the practicality of the things we do on this earth to see whether it is in fact a stationary plane or a spinning ball. Let me just scroll down to my response to Wolfie's video on his channel and I'll expand on that. Thank you for answering, Wolfie. Fair shout. Now, please don't get me wrong with the rest of my comment here. I'm not in denial or anything. This is just one small aspect of the entire issue when it comes to flying over a spinning ball. Agreed that the maths cannot be disputed and can be accurately calculated. But, as you say, it's negligible and actually would not appear to make much difference to the overall flight, fuel consumption and time. So actually measuring it is another story and ultimately comes down to having faith that it's a ball and not a flat plane. Another very difficult thing to practically prove. So in reality, it can fit or work either over a globe or a flat plane, something I continually try to put across as a matter of perception or choice of what one might want to believe. So it isn't going to be a single slam dunk proof either way. So you see, this has always been what I have attempted to do with my videos, is to demonstrate the thought process and thought experiments that people will do when they step back and really try to think about and find out for themselves whether anything we do on or above this earth has anything to do with it being a flat stationary plane or a spinning ball earth. Now I do choose my words carefully, and I was talking about the practicality of it, and of course you have said that it is factored in, yet in the real world it's something that doesn't really make a difference. And as I mentioned in my comment below the video, this is just one small element of the many factors that must be not only taken into account, but proven to be part of our practical reality when it comes to the belief that we are on a spinning ball earth. Among those are the alleged spin, the idea that the atmosphere sticks to the spinning ball, even though we have winds and clouds going in all kinds of directions. The idea that there is a Coriolis effect to take into account. The idea that gravity will stick us to the bottom of this ball and we feel no movement and we feel no difference when we are almost upside down in somewhere like Australia. All of these are to be imagined if we are to believe that we are on a spinning ball earth, and can never really be proven to be part of our everyday real life. So this really does highlight the crux of the issue, and that is one of perception, and the question as to whether our perception has been manipulated or dictated to us. From an early age, we are taught and told to perceive and believe that we are on a spinning ball earth, whizzing around a massive sun in a heliocentric system. But really, that is nothing more than an interpretation of what we observe in the skies above our heads and across the surface. And of course, to do that, we need to use our eyes to make those observations. And if we are to ignore perspective, then our reality is, in fact, being manipulated and dictated to us. Thank you very much.